Knowledge is power. It's not just a phrase that some of us learned before departing conjunction junction when we were younger, but today the knowledge led by expertise is powering artificial intelligence applications to help valuable research in the world of science and healthcare. Joining us today are members of the Matrix AI Consortium for Human Wellbeing at UT San Antonio, who are using the power of their knowledge to provide guidance for the next generation and build smarter AI that can translate that knowledge for people of all skill sets. We now welcome Matrix Thrust Leads in Augmenting Human Capabilities, Amina Qutub and Mark Goldberg, and the Thrust Lead in Machine Learning and Deployment, Amanda Fernandez. Thank you for joining us today.
Thanks for having us.
Good to be here.
So I want to start with an icebreaker question. We spoke with the other Thrust Leads in Matrix recently, and I had asked them, what is a piece of advice that you give students, whether it's personal or professional, that you hope will last with them for their lifetime? Now, I want to reverse it on you three and ask you the same question, but what is one piece of advice that you've received in your career, whether it's personal or professional, that has stuck with you that you could share with our audience? Amanda, let's start with you.
As someone who came out of industry, I had less teaching experience. And so one of the primary pieces of advice that I received from colleagues who have been doing this for far longer than they mentioned printing out a copy of your rubric for a class, circling one student's name per week and trying to make a personal connection with that student. And to date, that's been the most effective way for me to create a lasting connection with each student taking my class, despite growing course numbers in computing and related classes.
Getting the names right is always important.
That and really connecting with them and what their interests are in that class and why are they taking it, especially for electives, classes they don't need to necessarily take. It's good to learn a little bit more about them.
That's a good one, Amanda. Mark, do you have one?
I learned over the years that the most important rule I learned was don't follow those rules. I advise a lot of people who are making their way through academic careers, and there's a lot of expectations and a lot of rules. And what I learned early on was you need to follow what seems right to you. Don't listen too much to what I have to say.
Easier to ask for forgiveness than to ask for permission, right?
Unless you're in my lab, I would prefer that you ask first.
That makes sense. Amina, what piece of advice would you give?
So John, I remember my postdoc mentor, Sasha Poppel from Hopkins, gave this great advice about collaborations. He was describing to make sure you find synergies in your areas and not overlapping areas of expertise. And I think the Matrix really brings that to the front and forefront of what we do, because you're not competing with another computational biologist, as an example. You're collaborating with a neurologist or an educational expert who has really synergy in what you do.
Well, I'm glad you brought up Matrix. We're going to talk about Matrix in just a second, but I do want to ask one more question because I was trying to find some common ground with all of you. As we entered this room, I know Amanda and Mark had a conversation, about, Amanda, what you study with computer science, and Mark says there's something that I am not very familiar with. So I do want to find some common ground to start. And where I found the common ground was, of course, you all are educators. You all interact with students, and this is the future of our world. What you guys are doing today, y'all are lighting the torch to hopefully pass it on to them to lead what the work you guys are doing with Matrix. So I'm just kind of curious, and I wanted to start off, and Amanda, we can start with you. What are some of the conversations that you've had with students and observations that you've made from their use of artificial intelligence?
Yeah, that's a great question. The students actually know so much about artificial intelligence and the products that are out there and the new tools and how to use them. And one of their biggest questions is really just, how do I keep up? And, how do I know what the next big tool is and how do I use it for this application? And most of the time, our conversations center around slowing down. Pick out what you're trying to do. Identify the task. Does it need AI? And then once you identify what you're trying to do, you can pick the best tool for it.
Do you experience something similar, Amina?
Arguably in the bio areas and biomedicine, that the growth of AI is there, but its ability to make an impact like a neurologist would in the clinic and a bioresearcher would when they're focusing on wet lab work isn't to par with commercial applications of AI. So there's this bridge, which I think the students see immediately. And so it's exciting opportunities. And that's what in my classes, there's a focus on, and how do you bring your expertise, your biological knowledge to inform the AI? there's so much opportunity for experts to inform AI. And I think that's cool, very exciting areas to think of it for the future for our students.
Mark, what about you?
So I have two hats. I'm a biomedical researcher, as Amina said, and in that case, we have to stay on top of AI. The computational tools we use enable us to do the research that we do. But in the medical world, we live in a different place where we're very worried that maybe AI will lead us astray or may take us in directions we don't want. And when students come and ask me about that, sometimes, of course, as students, they all have the latest technology, but they're not sure, is this safe? Should I be using it? And what I like them to know and what I like my colleagues to know is that our job as teachers isn't to teach, for example, neurology or medical details or anatomy. My job is to teach how to think critically about things. What I teach my trainees today won't be true 5 years from now or 10 years from now. But if I give them the lesson on how to think critically about an advance, whether it's a medical device, whether it's a new drug which might be used, or whether it's a new technology like AI, it's the same. We're going to ask ourselves, do we like this thing? Great. Do we trust it? Great. Can we see some rules that will help us know whether this is going to help our patients be better? And in the same way that when Google Maps first came out, if you followed Google Maps, you might just find yourself driving off a dock into a lake. And you learn pretty soon what not to do and how to trust it. And over time, this gets better. And the same is true in AI for health.
Funny that you mentioned something that I wanted to get into a little bit more. And I know, Amanda, in our previous conversations we've had, talking about how we learn the limitations of AI and that it's important to have knowledge, to have experience, enough experience to know when something is, hey, I know that's wrong, and not just completely trusting it. How have you seen students understand those limitations?
To Mark's point, everything that we teach today will be completely different 2 years from now, 5 years from now, because mostly I teach, neural architectures and neural networks and the underpinnings of AI, right? And so we're building out the components that are, transformers are the underlying component for an LLM right now, ChatGPT, and everything's built on this architecture. But if we believe that architecture is going to be the same in 2 years, that's just probably not true. There's going to be an evolution. So teaching the students how to understand what that's made out of and how it works, and then what the new things are going to be composed of, and understanding how to interpret it when it comes back out. That's what really, I think, connects with the domain expertise.
Amina, I was going to ask you, I know you're an expert in the field, but is it challenging trying to keep up so you can mentor students better in how to use these AI technologies?
Yeah, John, as a preface, I teach a class on using AI in bio. And one of the reasons why I like to teach that is because I'm always having to learn in the process. And sometimes some students bring in new technologies where I want to learn the underpinnings of that technology. So one of the things I think is often missing is that our students don't want to just be consumers of the newest technology. A lot of them want to be the designers. And so that's where I see an ability for us to shape the field and not only learn what's the state of the art, because a lot of the state of the art is, a small incremental change from the last version, especially when you're talking about these large language models. Every new version is transformative, although the press would have you believe that. Knowing the underpinning of what the mechanism is and the architecture, it's not just the algorithm architecture, it's the processing, the way you handle the data that comes into the architecture, the way you score the models. All of that's still an art. And I think that's missing. And so that part gets back to what Mark's describing, that you need to have the students have this understanding of how you think as a human to vet and design your own models.
So I learned a lesson from a colleague of Amina's who came and talked to us about artificial intelligence. But he said something really smart about artificial intelligence in health is we need to understand how humans make decisions, which is incredibly brilliant. And the truth is we don't think all the time about how we come to decisions. Maybe it comes from the gut. Maybe we've read a lot. But we are prone to errors as people, right? And our systems are prone to errors as people. And somehow understanding how AI moves towards decision-making, which is how we use it, helps us understand the errors that we might be making. And the way in which humans and AI interact also is an area which needs a lot of exploration. The more we understand about ourselves and the errors we make, particularly the ones we don't realize we're making, the better we're going to be at using AI and also designing our own processes for how things will go in the future. It's exciting.
I want to lead back into Matrix. And as I mentioned, all three of you are part of two different thrusts. We've talked about that in a previous episode. Amanda, we'll start with you. The thrust labeled machine learning and deployment. You're leading that effort right now. Can you tell us a little bit about that thrust, what it entails, and what is the work that you all are doing right now?
So machine learning and deployment is sort of an opportunity for us to take what the focus is from some of the other thrusts and break it out into spaces that are a little bit difficult to deploy AI. So for example, we're working heavily with AI for science initiatives at this time to be able to bring AI to scientists, for example, that have previously understood that AI is not capable in my space because I don't have enough data to train a large model, or I don't collect enough samples, or my data is in this weird format that I can't necessarily put in a spreadsheet, and so I can't use AI models. It's not possible, right? And realistically, if we research AI, we know that that's feasible, but making that connection can be really difficult. And so part of machine learning deployment is attempting to sort of outreach. And I'd like to do that through undergraduate students. So undergraduate researchers within computing have a high capacity for programming and working around some of these data analysis and data science problems. And then domain experts that are undergraduate students in those spaces are kind of an excellent mechanism for being able to kind of connect with the research, learn a little bit about computing, but stay experts in their field. And so the thrust is aimed at attempting to bring some of the secure and trustworthy AI, for example, to fields that aren't necessarily concerned about or shouldn't be concerned about. They should be focused on their domain expertise.
What are some of those fields?
We're talking with astrophysicists. We are talking to biologists, local entities and organizations. We're looking at projects for groundwater analysis, for example, within San Antonio. So environmental biology is in there. We're kind of bringing a spectrum of different expertise and the scientists that want to use AI. Not everyone needs AI for everything, but those are interested in integrating it to some extent with their research and trying to build more. It can be difficult to try to figure out how to wedge a computer into field work, let alone how to get AI in there, and where are we going to get all of this data, and why do I need all of this data? And what are you going to give me back, And so usually what we wind up doing is finding data analysis or data science kind of applications. So can we go from the field work and the little field notes paperback notebook that you have in someone's back pocket, and can we digitize that for you, as a starting point? And the undergraduate students learn to keep full digital notebooks and robust information about their lab research, and that benefits the field, right? And that lab, and so that they sort of see the benefit and then say, okay, well now what can we do with this and move in that direction?
When I think field work, correct me if I'm wrong. I mean, these are, when you're talking about science, especially
in a literal field,
especially biology, I think about rainforests. If somebody's in the rainforest area, and that's not cheap to do. So, and it's not cheap to get data, and it's not cheap to go out to, say, the rainforest or the Sahara or something like that.
Correct.
So I imagine that utilizing the AI is a way to not just save costs, but to allow you to kind of have these predictive models that could help in those capacities. Is that kind of what's being
Absolutely.
done?
Yeah. And also locally. So San Antonio is actually a karst area, and that means something special in the world of biology. That's something that isn't, across the United States. It's something that's devoted, and our main campus happens to be in that space. So we have a good number of endangered species, for example, that are here. We have migrations of butterflies and other animals that kind of go through. And then we also sit right above the groundwater recharge zone for the aquifer. So we have a lot of opportunity to be able to study right here, and just kind of keeping track of that data can actually contribute globally.
Well, that's awesome. That is some fantastic work. Well, I want to move on to the next thrust, augmenting human capabilities. And I'm gonna have you talk about that, but I wanted to make sure I mentioned that the first time we interacted was because of a grant that was awarded for the work that's going on at Matrix in regards to this thrust and the things that you guys are doing. Can you share a little bit about that project, but also just in general talk to us about your thrust?
Sure, John. Our thrust is augmenting human capabilities, like you mentioned. And you're right. We first met when we were launching this project for AI for trauma care called iRemedyACT. And that's expanded. So far, we have 7 hospitals across the state of Texas working with us to be able to collect data on trauma cases. So we have over 400,000 cases now and learning from prospective data. And we've been training AI to be able to augment the performance of trauma care physicians and learn from all the crowd of these experts and be able to make a decision very quickly on a trauma case, to be able to improve transfers. So we're at a point we've gotten validation or clinical validations from our colleagues on our AI so far. Super exciting. We're in our phase 2 now. We already got awarded through our 3rd year now of our project. So that's one example of the type of projects we have for the Augmenting Human Capabilities Thrust. I want to bring it back to what Mark mentioned, this idea of learning from the humans as well to describe our thrust. Mark mentioned a statement actually from Eric Horowitz, who was one of our guest speakers or keynote speaker at a recent event that was hosted by our thrust. And he really did a great job of sharing how we can start to learn from the way humans make decisions and use AI to then augment the decisions. So you can imagine, as an example, right now we're sitting in this room, we're all listening, and the acoustics in this room are optimized for us to do a podcast, which is different than if you're outside where there's the noise you mentioned. We're in a unique environment where you have all this nature that's unique to San Antonio. That environment changes the way we sense and the way we communicate with each other. And a lot of AI doesn't bring that in yet, but you can imagine enhancing our capabilities so we could hear like a different animal could, or we could smell like a dog could, or we could touch something using AI, and we can augment the human senses. So that's one example of the types of projects we can do in our Augmenting Human Capabilities Trust. Mark, do you want to add anything to that?
Sure. It's a huge field. And I'll just talk about a project that's near to my own heart. I'm a stroke neurologist. I take care of patients who have stroke. And one of the big challenges with stroke is how to treat them acutely and make sure they get the right management. And I'm going to touch on that the resources that are available across the state aren't the same across the state. And if you happen to have a stroke in a place that's not well staffed medically, you need actually some help to make sure you know how that patient's going to get to the right place at the right time as quickly as possible to get those treatments. And that's what we are working on together, along with the trauma project, to extend that to the world of stroke. And it's a big deal. The bigger problem for me is that patients who have had a stroke often are left with disabilities that can't be fixed by repairing that part of the brain that just doesn't grow back. And so instead, our brains have tremendous capacity to regenerate the connections between the cells rather than the cells themselves. And this plasticity is what drives recovery, but it's not enough. And if we could understand how that plasticity occurs, we could find new drugs, new treatments, harness those things to help people get better after a stroke, maybe long after they've had a stroke. And that would be an amazing thing. But the brain is very complex. And our understanding of the brain draws on these phenomenally complex sets of maps and connections and a separate set of phenomenally complicated genes that are expressed. And honestly, we would not be able to look at these questions or even to consider them without the tools of AI. I'm not an AI expert. I'm a user of these wonderful tools to help me advance my science. And without these, we simply wouldn't have any idea about how to move next. These are millions and millions of connections and millions of genes. And putting these things together to make really smart understanding of what's going on has been transformative in my field.
And you can think vice versa. In our thrust, we also learn from the biology we're studying. So the cells communicate in very unique ways, especially neural cells, especially while they're regenerating connections. So can we augment AI using what we know about the biology of the human?
What are some of the things that you two have learned while working together on this thrust? Whether it's the iRemedyACT or a different project, can you give us an example of those collaboration efforts?
So as one very distinct example, when we're vetting our AI, we ask clinicians to also respond to trauma cases. So we can compare a clinical response from one of our expert colleagues, like Mark and our collaborators at Brian Eastridge at the medical center, and we literally compare their text to the AI. And we also give doctors a ability to rank each other and the AI. And so we can computationally, quantitatively compare the differences. And what you'll notice is if somebody's trained in neurology versus acute trauma care versus a general practitioner, they're going to respond differently. They're going to respond differently, of course, to a query than an individual who's not trained. And so we've learned how to be a translator, not only using the AI, but also when we communicate in collaborative discussions, we start to learn the language of the other researchers, of the clinicians. It's really eye-opening to see that perspective, not only when you're talking, but literally we can see that mathematically and those differences when we're modeling the collaborative work and the crowdsourcing of the experts.
One of the big challenges in collaborative science is finding time and space for people to collaborate well. And sometimes there's an imagination that scientists don't like to work together, and nothing could be further from the truth that scientists love to collaborate. And in fact, we get our best ideas when we go far from our own fields to areas that simply we would not have otherwise thought to do. And that's the strength here, is that when people from very, very different disciplines interact, you bring in ideas that you wouldn't have considered. And that happens all the time through Matrix. And it's really gratifying for someone who comes from the medical center side to interact with people who come from not just computing, but bioengineering, architecture,
psychology,
art.
Yes.
And these things really have an impact. And one of the things that I think is going to be very exciting about the work that we're doing in this thrust is finding ways for artificial intelligence to communicate to people in ways that they can understand. And this is a real challenge for us right now, is that people have really different ideas about science. They have different ideas about what AI can do. But if you are facing a disaster, a flood or an earthquake or something has happened, one of our projects is to figure out how you could best get that message, right? What would be a way for you to receive a message to saying something is happening now that you need to pay attention to? And this is where humans and computers need to interact to really be able to craft a better way of receiving information. I think that's a great promise for our thrust.
Well, I'm glad that we've had this platform to showcase what you guys are doing in Matrix and just in general, these podcasts that we've been able to do. I do want to highlight a little bit more, though, because for our audience that is not seeing you in your element every day, obviously this is not your element in this podcast room. What is it that you can tell our audience that can make them think or ponder about or get excited when they think about the future because of what's happening in this consortium?
Well, everyone has a unique experience, and their insight can now be captured, and their experiences can be captured quantitatively. And so it's really gratifying to see how students can bring their own perspectives as teams or as their unique individuals to AI. And so there's this opportunity, I think, for them, given their own experiences right now, to shape AI and to shape AI so it reasons in a way that they reason. And so that's a new opportunity. The other thing is it allows them to communicate with other people through different modes of communication that we didn't have available to us even 5 years ago. And I see this happening all the time. My students will ask a question of AI and they'll come back and have a different question than they would have independently. So that's another opportunity I see.
Amanda, what about you?
Yeah, so I think this is a great question because I kind of see it through the lens of the AI use and domain adaptivity, but I'm also so low level. We're coding everything, in graduate school, we did this on bare metal, right on top of the GPUs, right? And so I kind of see the other side of it where we've literally been shaped by the domain expertise. The neural networks that exist today have been shaped around the problems that were brought by folks that wanted to apply AI to various fields. And that's one thing that I love about this thrust, the machine learning and deployment thrust, is that we have the opportunity to learn what the real problem is still in the field and why existing solutions don't work. And then we can shape with the new architectures and the new, levels of AI and the new products that kind of come out. And that's just sort of a really hopefully inspiring message for folks that want to get involved or see shortcomings in the current architectures or current products that are out there. Hopefully they see that they have influence. They're going to be changing those core pieces and architectures that they're using.
So I think the thing to appreciate is that one of the values of a group like this is, as much as we may come off as nerdy scientists and intellectuals and teachers, we also have a really deep concern for the human impact. And built into the fabric of what we're doing is we're continuously looking at how is this going to make the human experience better, but also what are the risks? What are the dangers? What are the issues we have to make this platforms that we build to be secure? How can we trust them? What makes them trustworthy? How can we be sure that you trust the work that happens here as well as we do? And because we know more about AI than people who are users like me of this technology, we also have the ability to think forward and to think ahead. How can we take this directions which are safer, secure, and in general, more helpful for human experience? And I think that we don't always say these things in a really public way, but we're deeply concerned about them. And I think that we have the ability to be sure that we shape a future that we all want to be part of.
Well, that's a great way to end this. We want to thank you all three for joining us today, and we look forward to seeing what the work that you all are doing right now will bring to the rest of us in the future. Thank you.
Thank you, John.
Thank you.
Terrific. What a great conversation. Thanks.
Matrix celebrates a big milestone this month, the consortium's 5-year celebration. Follow Matrix on LinkedIn or visit ai.utsa.edu to see how you can be a part of the movement. This episode of Launchpad is brought to you by the Office of University Strategic Communications at the University of Texas at San Antonio. This podcast is available on Apple, Spotify, SoundCloud, and YouTube. Subscribe now and don't miss an episode. Stay up to date with the latest news about UT San Antonio by visiting news.utsa.edu.